In the last lesson, Sasha and Keoni worked with the parabola that you see here. When the teacher provided the y value of a point on the parabola, like y equals 7, Sasha and Keoni were able to find the x value for that point. In this lesson, they will generalize what they did in lesson 2 to create a method for finding the x value for any point on this parabola, given the y value of that point.
So your goal today is going to use the definition of a parabola to create a method for locating the x value for any point on the parabola, given the y value for that point. Let's pick just a point out here that's not on any grid. Yeah, and maybe you could make the coordinate pair with the y. Just put y for the y value.
So, y.
Okay. Now, I'm trying to see if you can generalize what you did before. Like, how would you find the x? What's the method?
So this distance, and then that distance, and
So we'd find the distance between our point and the directrix.
Okay, what do you think that distance would be?
Oh Lord. 7.5. Well, that's what it looks like to me.
8.5.
Well, because
What's under the
oh, you're right.
Now, this
You're right.
point is not meant to be that. It's meant to stand for any point.
Expressing the distance from a general point on the parabola to the directrix is challenging. At first, Keoni thought that the point looked like it had a y value of about 7.5, in which case Sasha thought that the distance from the point to the directrix would be 8.5 units. But the teacher wants them to think about this point as standing for any point on the parabola, not just one with a y value of 7.5. To help them think about the distance from a general point to the directrix, the teacher will ask Sasha and Keoni to remember what they did in lesson 2. For example, when the y value for a point on the parabola was 5, then the distance from that point to the directrix was 6 units. When the y value was 7, then the distance from that point to the directrix was 8 units. When the y value was 10, then the distance from that point to the directrix was 11 units. Sasha and Keoni will generalize their previous work to express the distance for a general point to the directrix in terms of y.
So let me go back and I'm going to pull up one of your other ones here. So this was your first one. And this was when y was 5, you were trying to locate the x, which you successfully did as approximately 4.5. But what was the distance there from the y equals 5, from the point to the directrix?
6.
Okay. And when y was 7, what was the distance?
8 units.
And what was that distance when y was 10?
11.
Can you generalize what's happening?
Yes.
Okay.
So wherever the point is on our graph, so say if it's at 7, then it's always going to be
8 away from the directrix and the focus.
your point or your y plus 1.
Why don't you write that down? And I'll see what Sasha thinks about that.
Yeah.
So, Sasha, you agree. Why is that distance from the point to the directrix y plus 1?
Because it's 1 under the 0, 0, so then it's just going to be 1 more
You
than...
can mark that.
Yeah, okay. So in that one space, it'll add 1 to whatever y you're given.
Show me y. Show me the distance y on your...
The what?
Wait, what?
You said it was 1 more than y.
Yes.
Okay, so
Where's
then
y?
this one, so it'll be...
Our y is up here somewhere.
So, well, it's like 7 something. But it's, I don't know.
Because there's our y line.
Mm-hmm. Can you phrase it again?
Yeah. So, Keoni, tell me what the y plus 1 means that you wrote there.
Okay, so our y is the distance from the origin to our point on the y line. And then we're adding 1 because there's a space down here for our directrix.
Okay. So I heard that the y plus 1 was the distance from the origin to the y line. Can you draw that in?
The y line?
Whatever you mean by that?
So like that and that? Or?
So our y is the distance from our origin to, well, for example, this line.
Why that line?
So if y equals 7,
Because it's on the line.
Ah, okay. But let's say y doesn't equal 7. Can you move it to where the point is?
yes.
Yes,
Yeah.
that's good.
Okay, now I just want to hear it in Sasha's words too. What do you think the y plus 1 means?
Oh, so since when we were doing the Pythagorean theorem, our y plus 1 is going to be our c, or our distance from it.
It's going to be what?
Our c and our a
C
squared plus b squared.
Can you draw in what the c is?
Oh, okay. Should I not just use this color, right?
So
that's going to be y plus 1.
Now, why do you know that? What gives you that?
Because we know that that's the distance from the directrix, and then it's going to be the same for the focus. And since it's 1 under the
origin.
the x-axis, the origin,
Or the
all of that.
x-axis, yeah.
we know you're just going to add 1 to whatever y you're given.
Okay. Can you, can whoever's got the pen, just show me with your hand where, draw the distance y plus 1, and then just show me where the 1 is and show me where the y is?
So this is the y, whatever, well, anyway, yeah, so
Drop right here.
you do. So.
Okay, so the y is the distance from our origin to our line.
Okay.
And then the plus 1 is this right here.
Ah, so the y plus 1, can you just gesture along the distance y plus 1?
So y, then plus 1.
Ah, okay, I get it.
Sasha and Keoni have made an important discovery. The distance from a general point on the parabola to the directrix is y plus 1. That's because the distance from the point to the x-axis is y units, and the distance from the x-axis to the directrix is 1 unit. Together, the distance is y plus 1. The distance from the general point to the focus is also y plus 1 because of the definition of a parabola.
So I think you have figured out a lot so far. Now, your ultimate goal is to find what x is.
Okay. So our y plus 1. Okay, so we have oh no, I don't.
You don't got it? He kept saying he's got it,
Because
but he doesn't got it.
What are you trying to find, Keoni?
this,
Y minus 1.
the units here. Okay, because we don't, let's be here.
Yeah, but so this one is another space because it's on the 1. So then that's another point, but instead of adding 1 like that one, it takes away 1.
Why are you taking 1 away?
Because it's above the origin. So it's like if you're given 7, then this one's going to be 6.
Keoni is confused about the meaning of y minus 1, which can be harder to see than the distance y plus 1. Sasha re-explains the meaning of both.
Our point right here, y on y, that our distance from the directrix and to the focus is going to be y plus 1.
And why is that?
because it is 1 under the x-axis. So you're going to add 1 to whatever y you're already at, or whatever y you're given. And then for your, the one over here, since your focus is 1, there's so much writing right there.
I know, just...
Since your focus is 1 over the x-axis, it's going to be 1 minus, or it's going to be y minus 1. And then that'll get you this side.
Good.
Sasha explained one way to think about the length of this side of the right triangle. The distance all the way to the x-axis is y units. But the distance we are interested in stops at the focus. As Sasha put it, the focus is 1 over the x-axis, so you remove this 1 unit from the line that is y units long. What is left is the side of the right triangle that we are interested in, and that side is y minus 1 units long. So Sasha and Keoni have figured out that one side of the right triangle is y minus 1 units long, and the hypotenuse is y plus 1 units long. In the next episode, they use this information, along with the Pythagorean theorem, to find the missing length of the right triangle. This length will tell them the x value of the general point on the parabola.